Welcome to the fifth part of this series. In this section, we will focus on troubleshooting persistent volume mounts. The first question will address an issue where the persistent volume claim, PVC, is incorrectly specified in a pod. The second question will cover a scenario where the PVC requests more storage than the persistent volume can provide. The third question will relate to the access mode of a persistent volume. Additionally, we'll explore some storage-related and network-related questions. You can skip the network-related questions if you followed my previous series, but they are still relevant, which is why I've included them here. I will introduce different network scenarios in future parts. You can find the environment setup files on my GitHub account. Starting from this part, I will include environment setup files in the repository, so you can replicate the exact scenarios I demonstrate on your end. Without further delay, let's dive into the 25th question. The 25th question is, you can find a pod cube 01 pod on the cluster. Please check the status of the pod and fix the issue. You can recreate the pod if needed. So in this question they are allowing us to recreate the pod, so definitely we have to recreate it. Okay, let's go to the cluster. Let's check the pod first. Yes, we can see a pod with status as pending, so let's describe it to find the reason. Okay, here we can see, the pod has failed to schedule in a node due to unable to find prod PVC-01 persistent volume claim. So let's check the available PV and PVC. Here we can see one persistent volume, and that is bonded with a PVC. Let's check the claim next. We can see prod PVC claim is available, so the mistake is in the pod configuration file. Let's check it that. Actually pod is looking for prod PVC-01 claim instead of prod PVC. As per the question they are allowing us to recreate the pod if needed. So we have to recreate the pod with correct claim name. Okay, let's edit the pod. We have to edit here, but this will not auto-deploy. Instead it will saved into the temporary directory. Let's copy that to a new YAML file. Okay, now we have copied to new YAML file. Let's verify the new YAML file. Next we need to delete the existing pod. Perfect. Let's apply new YAML file. Yes, it is working. Congratulations, we are successfully completed this task. Next I will show you how to make this scenario in your end for practicing. Next is environment setup. You will get all YAML files for making these scenarios from our GitHub repository. Go to GitHub and search for Kubernetes Way, and open CKA series. Here you will get all YAML files for making the environment. Just download it and apply to the cluster. Link in the description. Once downloaded, copy it to cluster and just apply it one by one. First apply pv.yaml file. Persistent volume is created, then apply PVC file. Yes, PVC is deployed and bonded with PV. And finally 25.yaml file. That's it. This way you can create the scenario. Okay, let's go to the next question. Next question is very similar to the previous one, but this time they are not allowing us to make any changes on the pod. The 26th question is, you can find a pod cube 02 pod on the cluster. Please check the status of the pod and fix the issue. Okay, let's go to the cluster. Okay, we can see our pod is in pending status. Let's describe it for getting more details. Here we can see another error related with PVC. In previous question the error was missing PVC, but in this question the error is related with mounting the volume. Okay, let's check the volumes. Here we can see the prod PVC is in pending status. Let's check the persistence volume. Okay, PV is there, so what will be the issue? Let's check the pod first. Here we can see the claim name is as prod PVC, so there is no issues with request configuration. We don't need to doubt on pod configuration part. So next check in the PVC configuration. Okay, please note here, the claim is question 20 GB storage, and the access mode is read-write once, and the storage class name is manual, so this should be aligned with persistence volume. Okay, let's check this in the PV. So just edit the PV. Here is the catch. Actually PV size is 10 GB, but our claim is for 20 gigabytes. This is the issue. So let's recreate the claim. As we did it in the previous question, we saved the temp file to new YAML file. Let's verify it. Perfect. Next we need to delete the PVC and apply new YAML file. OK, PVC is deleted. Let's apply the new YAML file. Yes, now our claim is bonded to the persistence volume. Let's check the pod status now. Yes, now the status is changed. Now it is running. We have successfully completed this task. Next I will show you how to create this scenario in your end. Go to our GitHub link and take the 26th question files. As you did in previous question, just run it one by one. That's it. Now your environment is ready for practicing. Okay, let's go to the next question. Next question is also similar to the previous, but the scenario is different. The next question is, you can find a pod cube 03 pod on the cluster. Please check the status of the pod and fix the issue. This time also there is no permission to recreate the pod. Okay, let's go to the cluster. Let's check the pod first. Pod is in pending status. Let's describe it for more details. You can see the pod is not bonded with the volume, so let's check the persistence volume claim first. We can see the PVC is not bonded, and it is in pending status. Let's edit the pod to verify the claim name. Yes, the PVC name and PVC claim name on the pod are same, so it is related with PV and PVC. So let's check the PVC. Some warning we can see, and access mode is not showing. Okay, let's edit the PVC. Let's cross-check the spec section. It is asking for 10 gigabytes. and the access mode is read-write once. Let's check this details and persistence volume also. This PVC only mount to PV when the specification is aligned. OK, PV has enough storage, but the access mode is different. PV access mode is read-write many, but in the PVC it is mentioned as read-write once, so we have to change it. Let's copy it to new YAML file. Then delete the PVC, and apply new YAML file. Before apply, just verify it. OK, seems perfect. Let's apply. Yes, now our PVC is bonded to the PV. Let's check the pod status. Now pod status is changed, and it will be running soon. Yes, it is running. We have successfully completed this task. You can find the YAML files of this task from our GitHub repository for making this scenarios for practicing. OK, our troubleshooting scenarios for this part is completed. Next we will go to the storage part. Thank you. Next question is comparatively a small task. The question is to create a persistent volume with the given specification. Volume name should be pvdev, storage is 100 megabytes, and access mode should be read-write many, and the path should be /pv/devdata. This is a straightforward question. Let's go to the cluster. Currently we have no volumes. OK, let's take the help from documentation for PV creation. Search for PV. And choose this link. OK, we can use this sample YAML file as a reference. Let's copy to a YAML file. Name should be pvdev. We don't need the labels. Storage is 100 megabytes. Access mode is read-write many. And the path should be /pv/devdata. Storage class is not mentioned in the question, so just remove it. Seems perfect, let's apply it. Yes, our persistent volume is ready. We have successfully completed this task, and we will cover a few more questions related to PV and PVC in later parts of this series. Next questions will be from the network session, but I am using the same 2 questions that we used in the previous series, but they are still relevant, so let's go to the network part. You have a Kubernetes cluster that runs a 3-tier web application. A front-end tier it is running on port 80, an application tier that is running on port 8080, and a back-end tier on port 3306. The security team has mandated that the back-end tier should only be accessible from the application tier, which means we need to implement a network policy on the back-end pod. Please look at this diagram. Normally any container can communicate with each other in a Kubernetes environment, unless we apply any network policies. In this case, we can see the front-end pod, and the application pod can access the back-end pod without any restrictions. If we want to block ingress from front-end, and allow ingress only from the application pod, then we need to apply an ingress network policy in the back-end. This policy will allow the ingress connection only from the application pods, so not only from the front-end pod, but also from all other pods incoming other than the application pod, will be blocked through this policy. I will show this. We have 3 pods in the cluster: application, back-end, and front-end. Now we can see in even more detailed. First of all, we need to check whether the application pod and the front-end pods have a connection to the back-end pod or not. Now we are going to use Telnet for checking the connection from the front-end pod. Okay, you can see Telnet is not available in this pod, so we have to install the Telnet first. Let's update the container base image first, then only we can install the Telnet. Now we are going to install Telnet. Done. Let's try again the Telnet to the back-end pod from the front-end pod. Connection is getting. Let's do the same from the application pod. Let's update the container base image first, then install the telnet. We can see the connectivity to the backend pod from the application pod also. In order to solve this question, we need to take the help of the documentation. Search for network policy. Network policy is a big topic. This is the sample YAML for implementing the policy. If you scroll down, then you can see some technical terms like ingress and egress. Ingress is inbound connection and egress is outbound. If you want to block any ingress, then you can use this YAML. And if you want to allow all ingress, then you can use this YAML. So many samples are here. Let's come to our question. We want to apply an ingress policy in the backend pod. Before that, I will show you one thing. You can see, each pod have a separate labels. Actually, this network policy is working based on these labels. Okay, let's copy the YAML file. We don't need egress, so just copy and paste this much into a YAML file. Just give a meaningful name for your network policy. Give the matching label as tier equals backend, because this network policy is applying to backend pods. We don't need egress. We don't need IP block and namespace selector, so just remove both. Under ingress, we need only the pod selector. Edit the matching label, label it as tier equals application. and change the port to 3306. Now we are going to apply an ingress network policy on backend pods, which means after this policy is applied, it will only allow the ingress connection to port 3306 from the application pods. The rest of all pods will be blocked. Let's apply this YAML file. Policy applied. Let's check the connectivity now. Let's try from the application pod. Okay, connection is getting. Let's try from the frontend pod. Yes, our policy is working. You can see the connection from frontend is blocking by our policy. Let's describe the policy in more detail. You can see the policy is applied to the pods that are labeled tier equals backend, and allowing the ingress to port 3306 from the pods that are labeled by tier equals application. So we have completed this scenario, and next time we will cover even more complicated scenarios on network policies. The next question is: you have a Kubernetes cluster and running pods in multiple namespaces. The security team has mandated that the DB pods on the Project A namespace be only accessible from the service pods that are running in the Project B namespace. This is a little bit difficult question. I will explain the question with a diagram. As per the question, you may have more than 2 namespaces in the cluster. In this diagram, you can see 3 namespaces, Project A, B, and C. By default, all pods in all namespaces can communicate with each other. As per the question, we have to only allow ingress connection from the service pods of the Project B to DB pods of Project A. So we need to block other pods of Project B as well as other namespaces. Let's go to the cluster. Let's check the namespace first. We can see 3 namespaces. Next, we need to find the pods of all namespaces. Project A has 1 DB pod, Project B has 2 pods, Service and Web, and Project C has 1 pod, Application. This is the IP address of DB pod. First, we need to check the connectivity using the ping command. We can see the service pod can communicate with DB pod. Let's check other pods' connectivity. Okay, the web pod has connectivity to DB pod. Okay, application pod also has connectivity to the DB pod. According to the question, we can only allow the connection from the service pod of project B, and the rest of all namespaces in the pod need to block. We need the help of documentation to solve this scenario. Go to the network policies. Copy the YAML file. Save and exit. Before editing, we need to add some labels on namespaces. In order to implement network policies in this scenario, we need to label the namespace first. We added one label in the Project A namespace, and we need to do the same in Project B namespace. Next, we need to find the labels of the pods in the Project A and the Project B. Please note this all labels, because network policy is working based on the labels on the pods. Let's edit the YAML file. First, edit the namespace. It should be Project A, because we are applying this policy on Project A namespace. Match label should be the label of DB pod. We don't need egress. We don't need IP block. Namespace match label should be the labels of Project B, because we need only the ingress connection from Project B. pod selector should be the label of the service pod, because we need the connection from the service pod to DB pod. Two conditions are there, and OR condition. You can see, now the settings are in OR condition. Which means, any one of the conditions is true, then the policy will allow the connection. So we need to remove the dash in front of the pod selector in order to make the condition as AND. Which means, the policy will only allow the connection when both conditions are true. Let's save and exit. Okay, we have applied the policy. Let's check the connectivity now. First, we are trying from the service pod. Okay, connection is there. Now we are going to try from the web pod. You can see, connectivity is blocked by network policy. Next, we can try from the application pod. Yes, that also is blocked by the network policy. We have successfully completed this question. And I will show you one more thing. I will show you what will happen if we are not remove the dash from the YAML file. Let's see. Let's delete the existing policy. Now I am going to show you how will behave the policy if we added the dash. Now it becomes an OR condition. That means, either one condition is true, then it will allow the ingress. Apply again. Application pod is blocked. Service pod is allowing. Web pod is also allowing, because the network policy is checking whether it is coming from namespace project B or service. Either one condition is true, then it will allow the ingress. In this case, web pods is from namespace B, so the policy will allow the connection. Thank you for watching this video. We will cover more questions related to network policies in the upcoming videos. If you felt this video is useful, then please do like and subscribe.